Right, Honors Integrated 2. What are we doing today? We are solving nonlinear systems algebraically, and that means using algebra. That's what algebraically means. And for this, it's a system. We're going to use substitution to solve these. This isn't super complicated, but it's a little bit, it takes a little time. It's a little time consuming, but we were solving these nonlinear systems on Tuesday. We were doing that graphically and using Desmos. I want to let you know that you can still check your answer with Desmos, but you better send me a picture with all the algebra on your work or you won't get any credit, all right? But you can use Desmos to check your answer. But what does this mean? Again, we're going to use algebra. I think if I show you a couple of examples, it'll make perfect sense and you're going to get this. Let me show you an example. Okay, here's my first example. It's actually number 2 from your homework from Tuesday. You used a graph to do this. We're going to not use a graph. We're going to use algebra and therefore algebraically. I said we're going to use substitution. So what I want you to first notice is that I've got 2 functions. Both of them equal y. So, here's y. It's saying y equals this and y equals that. Well, okay, if they both equal y, let's just substitute one of these, like for instance this one right here, for y, and see what that does for us. So I'm going to rewrite this thing, but instead of this, I'm going to put that right there. I'll even use the same color. So here's what I get. I get x plus 3 squared minus 4. This is right here now. I still need the equal sign, of course. So that equals 2x plus 2. So I substituted this for the y, right? And what has that done for me? Well, now I have one equation that only has x's in it. That's perfect. And now it's just a matter of solving it. I'm going to take a break. I'm going to erase this and rewrite this up on top so I have a little more room. Be right back. Okay, so here I go. I've rewritten it now, and you can see it's a quadratic because of the 2. What am I going to do? Well, I needed to make it equal to 0. Anytime you have a quadratic, it has to equal 0. So I have to simplify this. So the first thing I'm going to do is I'm just going to expand that, and I'm not killing puppies. You know, that's x plus 3 and x plus 3. If I do FOIL on that, I get x squared plus 6x plus 9. So this is this. But I can't forget that minus 4, and of course I still have all this junk over here. Now I'm going to simplify just this left side. I have a 9 minus 4, that gives me x squared plus 6x plus 9 minus 4 is 5, and that still equals these things here, 2x plus 2. Again, I do need to make this equal to 0, so I'm going to subtract 2x from its like term over here, and I'm also going to subtract this 2 from its like term. And in doing this, I've now made this equal to 0, x squared plus 4x plus 3, and that equals 0, and that's really important right now. Now that I have it equal to 0, now I can solve it. I am going to get 2 solutions, and now the deal is, how do I solve this? Well, this is where choosing your method comes in really important. We did that last week. You need to solve this. What method are you going to use? Can you take a square root? You can't because of that 4x. Can you factor it? Are there numbers that multiply to 3 and add up to 4? I think there are. 3 and 1. That looks pretty easy. I'm going to be able to factor this one, and that's going to be my method. But if you couldn't, you might have to do the quadratic formula. But here's what I'm going to do. I'm going to do x plus 1, and then I'm going to do x plus 3. That equals 0. And you know how to do this. I should get 2 answers. X equals negative 1 and 3. But wait, we're not done. We're not done because these are the x values. That is true. But if you remember, we're trying to find the points where a straight line and a parabola cross, and that means we have 2 xy's that we need to find. So I have the x values, that's cool, but now I need to substitute them back in and get the y values. Let me do that for you. I'll show you what's up. Okay, right before I took a break, I had made a mistake. I said just positive 3, but it is negative 3. Here are my 2 solutions, negative 1 and negative 3. And now I'm looking for 2 points, right? Where the straight line and the parabola cross. What I know is that the x values are negative 1 to negative 3, but I don't know the y values. How do you find the y values? Well, you're going to have to substitute these numbers here into one of these functions. You can choose. It doesn't matter. It should work for both of them because both of them are solutions. It seems to me that I'm going to do the easy thing and just plug them in right here. I'll take this -1 and plug it right there. It'll be y equals 2 times -1 plus 2. That's -2 plus 2, and that is 0. So when x equals -1, y equals 0. There's my other one right there. Now what I'll do is I'll take the -3 right here, and I'm going to plug it into the same one. Why would I mess with this? Forget that. It's just too much work. I'll just plug it in here. This is y equals 2 times -3 plus 2. This is -6 plus 2, and y equals -4. So when x equals -3, y equals -4. So here is my solution, the 2 points where the straight line and the parabola cross. Is it a little bit of work? It is. Do you have this? You do. All right, I'm back with example number 2. Let me just point out this little squiggly bracket here. That implies that this is a system, that they're working together. That's why they're called systems of nonlinear equations. And once again, I'm just going to use substitution. Since they both equal y, I'm going to take this and I'm going to substitute it right there for y. And that would look like this: 2x squared plus 9x plus 5. The equal sign is still there. I just put that there. So this is now equal to 3x minus 3. So you can see I substituted that for y since they both equal y. And now I have this long equation that only has x values. Now, I need to remind you that sometimes with these you have 2 solutions, sometimes you have 1 solution, sometimes you have no solutions at all. This is an example of when you get no solutions. Let's see how that works. Let's make this equal to 0. But to make it equal to 0, I need to subtract this from its like term. I need to add this 3 to its like term, like so. And what does that leave me? That leaves me with this 2x squared plus 6x plus 8 equals 0. And now I'm back to that. How do I solve this? Well, I'm going to take a 2 out first. You know, I've taught you many times, factor out a GCF first. And then remember, you can just divide by 2 and you just cancel that out. So what I'm really having to do is solve this. Can I take a square root? Let's go through our methods. Can I just solve this by square roots? No, because it's got that linear term. Can I factor it? Is there anything that multiplies to 4 and adds up to 3? Unfortunately, it's not. You know, there's 4 and 1 and 2 and 2, and you can't get 3. What does that lead us to, everybody? If you can't factor and you can't square root, what is our method that works every single time and even finds the imaginary numbers and solutions? Well, it's the quadratic formula. All right, so I'm going to rewrite this, and then we're going to do the quadratic formula. All right, I'm going to quadratic formula this bad dude right here. All right, so here's my a, there's my b, there's my c. You know the formula: x equals -b plus or minus the square root of b squared, that's 3 squared, minus 4 times 1 times 4. Everything over 2 times 1 like this. This is x equals -3 plus or minus the square root of 9 minus 16, everything over 2. X equals -3. What does that give me? X equals -3 plus or minus the square root of -7 over 2. Wait a minute, dudes. That's a problem. What's the problem? That's the problem. You can't take the square root of a negative number and get a real answer. You can get imaginary answers, but imaginary answers means no real solution. So that's where we're at. If you get imaginary, that equals no real solution. So as soon as you get to that, an imaginary answer, well, since it's imaginary, that means it's not real, and that's an example of a problem that has no real solutions. So in this is the answer for this problem. All right. There's another example in your book. You ought to take a look at it. Let me show you what your homework is too. All right, boom, there's your homework right here, just like that. Gonna make it easy. It's due Monday. All right, due Monday. Take care of this. Come see me during my office hours. Ask me some questions. If you have anything, text me with some questions. We can Zoom. You can ask me questions. You got questions? I got answers. All right. So just be aware. Take care of this stuff. By the way, these are word problems. You need decimal answers. Don't give me some crazy radical. If you're answering a question, it has to have a decimal. So I hope you guys are doing good. Keep up with the work. You're all doing great. And I'll see you on Zoom later.